At the dawn of the 20th century, humanity faced a precipice. The world's population was growing, but its ability to produce food was not. Sir William Crookes delivered a stark warning in 1898. Mass starvation was inevitable unless a new source of nitrogen fertilizer could be found. Nature's cycles, which had sustained us for millennia, were simply not enough. The soil was becoming exhausted. The great challenge was to find a way to feed the future, to pull sustenance from the very air we breathe. The air around us is nearly 80% nitrogen, an immense reservoir. But this atmospheric nitrogen is stubbornly unreactive. It's two atoms bound by a powerful triple bond. Plants and animals cannot use it directly. For eons, only lightning strikes and specialized bacteria could perform the vital task of fixing this nitrogen. This natural process was the great bottleneck of life on Earth, the ultimate limiter of growth. Then came a breakthrough that would change human history forever. Two German scientists, Fritz Haber and Haber-Bosch, achieved the seemingly impossible. They developed a process to synthesize ammonia from nitrogen and hydrogen gas under immense pressure and high temperatures. This was the Haber-Bosch process. It was an act of modern alchemy, turning thin air into the building blocks of life. For the first time, humanity was not merely a participant in the nitrogen cycle, we had become its master. The impact was revolutionary. The availability of cheap, synthetic fertilizer fueled the Green Revolution, leading to an explosion in agricultural productivity. Crop yields for wheat, rice, and corn soared to unprecedented heights. This abundance allowed human population to grow from 1.6 billion in 1900 to over 8 billion today. Nearly half the people on Earth today carry nitrogen atoms that came from a factory, not a field. Human activity now moves more nitrogen through the environment than all of Earth's terrestrial processes combined. We produce over 120 million tons of synthetic ammonia annually. This industrial torrent has become the silent engine of modern civilization. Our farms, cities, and very existence have been built upon this foundation of synthetic fertility. We have built a world that depends entirely on this constant, man-made intervention in a fundamental planetary boundary. Our mastery has a dark side. Less than half the nitrogen fertilizer applied to fields is actually used by crops. The rest embarks on a destructive journey, seeping into soil, washing into waterways, and escaping into the atmosphere, triggering a cascade of environmental problems. In our waters, excess nitrogen causes massive algae blooms that create underwater dead zones where marine life cannot survive. There are now over 500 of these silent, barren underwater deserts in our oceans, including one in the Gulf of Mexico, the size of a small country. Nitrogen's impact extends into the atmosphere. Soil microbes convert fertilizers into nitrous oxide, a greenhouse gas nearly 300 times more powerful than carbon dioxide at trapping heat. It's also a leading cause of ozone layer depletion. From the deepest oceans to the highest stratosphere, our use of nitrogen is unraveling the delicate threads of planetary systems that sustain us. The very molecule that gave us abundance now threatens the stability of the living world. The nitrogen story reveals profound global inequality. The world is split between nations drowning in excess nitrogen and those starved of it. Developed countries now grapple with pollution legacy, while developing nations like China and India rapidly increase fertilizer use, creating unprecedented pollution hotspots. Meanwhile, vast areas, particularly in sub-Saharan Africa, suffer from chronic nitrogen deficit. Here, soils are depleted and farmers lack fertilizer access, leading to low yields and persistent food insecurity. Simply telling the world to use less nitrogen is not a solution. Yet solutions exist. Precision agriculture using GPS and soil sensors allows farmers to apply fertilizer exactly when and where needed, dramatically reducing waste. Agroecological practices like crop diversification, cover crops, and nitrogen-fixing legumes create healthier, more resilient systems that work with nature. Our dietary choices matter too. Since much fertilizer feeds livestock, not people, shifting toward more plant-rich diets can significantly reduce our collective nitrogen footprint. Even modest changes, scaled across billions, would powerfully impact the planet's nitrogen balance. Fixing the nitrogen cycle is fundamental to our future, linked to climate stability, ocean health, water quality, and feeding humanity. The first step is awareness. We must bring this invisible crisis into the light for discussion in communities, governments, and globally. We have the power to turn this great gamble into a great success. We must learn, care, and act together. The health of our living planet depends on it. The nitrogen cycle could change humanity forever, and with wisdom and action, it can change us for the better.